Hello and welcome to the Edulifelk channel. Today we will discuss the combinational circuit, decoder and encoder, and multiplexer.
Introduction to combinational circuit. When logic gates are connected together to produce a specific output for a certain specified combination of input variables with no storage involved, the resulting circuit is combinational logic circuit. Some facts of combinational logic circuit. The output level is all time depend on the combination of input level. SOP and POS implementation are basic forms of combinational logic. No storage involved in the circuit. This diagram shows the example of combinational logic circuit. You can see the combinational logic circuit. What are the types of gates we use in this combinational circuit? Linear network can be completely characterized by parameters measured at a Karnaugh map. Provide a systematic method of simplifying Boolean expression and, if properly used, will produce the simplest SOP and POS expression possible, known as the minimum expression. This is the introduction to Karnaugh map, also known as K-map. It is defined by a single variable chain. The cells that differ by only one variable are adjacent cells. All the respective adjacent cells are represented below. This is the Karnaugh map. You can see the A, B line and CD. For an SOP expression in standard form, a 1 is placed on the K-map for each product term in the expression. Each one is called true, is placed in a cell corresponding to the value of a product term. Mapping of the non-stand SOP expression lies A bar plus A B bar plus A B C bar on the K-map map is this. You can see the expression in the table given below. Minimization. The process that results in expression contain the fewest possible term with the fewest possible variable is called the minimization. Rule for grouping the first cell. A group must contain either 1, 2, 4, 8 or 16 cells, which are all powers of 2. Each cell in a group must be adjacent to one or more cells in the same group, but all cells in the group do not have the adjacent to each other. Always include the largest possible number of ones in a group in accordance with the rule 1. Each one on the map must be include the least one group. The first already in a group can be included is another group as long as the overlapping groups include non-common ones. Example, grouping 1 is. This is, you can see the ABC, D and BC of the grouping. Basic tree method of limited logic circuit are logic circuit from Boolean expression, logic circuits from a truth table, logic circuits from minimized expression K-map. You can see the Boolean expression below diagram is X equal to AB plus CDE. The plus mean O, and A and B and CDE also AND. You can see the AB AND gate, CDE AND gate, O can be seen in the red color. This logic circuit from a minimized expression K-map. The usualist find the truth table according to the task, get the minimized expression using K-map, implementation of the combinational logic circuit. NAND gate are universal logic expression. You can see in the table NOT symbol and NAND equivalent, and NAND equivalent, O and NAND equivalent. And you can see the NO gate as universal logic element, NOT and O. Half adder. Adders are important in computers and also in the type of digital system in which numeral data is perceived. Truth table of a half adder. This is the truth table of the half adder. Input and output. 0, 0, sum is 0 and carry 0. 0, 1, sum is 1, carrying 0. 1, 0, sum is 1 and carries 0. 1, 1, sum is 0, carrying 1. This is the picture of half adder. Combinational logic circuit of half adder is below. This is a full adder, truth table of full adder. And you can see these pictures and tables and you can get knowledge of it. This is parallel adder. It case of cascade of adders. Example 1, 1 plus O 0, 1. Number is bits in number of adders. This parallel 4-bit adder. Handling carries. Ripple carry adder is this is very important part. Ripple carry adder is one in which the carry output of each full adder is connected to the carry input, the next higher order stage. The sum of the output carry any stage can't be produced until the input carry occurs. That causes the time delay in additional process as shown in below. Decoder and encoder. A decoder is a digital circuit that detects the presence of a specified combination of bits on its input and indicates the presence of that code by specified output. An encoder is a combinational logic circuit that essentially performs a reverse decoder function. A decoder, basic binary decoder. As I described earlier, a decoder is a digital circuit that detects the presence of a specified combination of bits on its input and indicates the presence of the code by a specific output level. Encoder. An encoder is a combinational logic circuit that essentially performs a reverse decoder function. Multiplexer. A multiplexer (MUX) is a device that allows digital information from several sources to be routed into a single line for transmission over that line common destination. Multiplexers are also known as the data selectors. This is the truth table of a 4-input MUX. DEMUX basically reverse of the multiplexing function. For the reason the DEMUX is also known as a data distributor. Decoder can also be used as a demultiplexer. Thank you.